And back in the old days, we would not have this filled out for you. All right. You would have to fill it out. What sine of a 30-degree angle? What sine of a 30? It's the thing I told you to one half. Did anyone look at the hand video? Like the hand video? Did anyone look at that? Raise your hand if you did. Okay, and evaluating. No, but just one. Did you? No. Okay. The hand. So this is how I didn't read. I didn't watch it. I never do the hand, but it does make sense for me for sine. This why am I shaking so much? Anyone see that pinky? That might be a problem. All right. But anyway, this is zero. What's the square root of zero? What's the square root of zero? 0/2. What's the square root of one? 1/2. So that's 30 degrees. That's pi/6. What's the square root of two? Square root of 2/2. What's the square root of three? Root 3/2. What's the square root of four? 2/2, which is what? One. So that's how you sine. This is how you can do sine. And then cosine, they do something different with cosine. Then they figure out tangent. I got them memorized. This is someone that doesn't have it memorized, so you might want to watch that. Then it'd be kind of cool if I saw some people doing this during a test, and then there's a way of working out tangent as well. I just know them all. I just know sine of a 30 is a half. So what's cosine of a 30? Anyone? The other one, root 3/2, which will come up here. So input, say it. So what's sine of a 30? 1/2. And what's 1/2 as a decimal? 0.5. What's sine of a 45? root 2/2. And then we kindly gave you the decimal approximation of that. What's the sine of 60? I'm doing the degree measures on purpose because we should think about degrees and then know they convert to radians. What sine of a 60? Say that ratio. Okay, and then that becomes 0.87 as a decimal. And then what's sine of a 90? 1. And then what happens in quadrant 2? What's sine in quadrant 2? Starts with a P. Positive. And then that's sine of another 60, another 45, and another 30. That's why those ratios are exactly the same. But what's sine in quadrant 3? Negative. And then what's sine in quadrant 4? Negative. So we could have filled those out, and then I could have told you to plot them on a coordinate plane. And I have done this with the ABers, where we had all of these marked: pi/6, pi/4, pi/3. And then they would have to, well, pi/6 is comma half, then that's 0.7, and then this is 0.8, and then sine of pi/2 is 1. Sine of 0 is 0. Get it? It's pretty simple. Okay. All right. And then sine of this is coming back down. And then this is back to sine of pi/6 is a half, and then sine of pi is 0. And then the negatives at negative or 7 pi/6, that's negative a half. Blah, 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 blah. So this is the kind of thing that we were looking for you to kind of figure out. And that's 11 pi/6. And then we're back to 2 pi. So you should certainly see that this is different than this. Those are different outputs. But then after this, from 2 pi to 4 pi, you're going to have a cut and paste. It's going to be the same thing, right? Because I'll show you on another link that they have here. And then this is just going into quadrant 4, but in a negative ratio. So that's why this point is the same as this. This is quadrant 3, but using negative angle measures. That's why this is the same as this. Quadrant 2, quadrant 1, but in a negative angle measure. So here's one period. I'll show you one other thing on our calendar that we have. Whoops. That's me getting ready for the notes. Not whoops. It's right here. Okay, this is a cool little thing that the other teachers shared. I've had other things like this. This is just as good. I wish it went a little farther, but when you grab the unit circle, and I'm going to turn sine on. Here we go. Sine of a 30 is a half. You're right around 30 degrees or pi/6. Sine of 45, sine of 60, sine of 90. Of course, pi/2 is the equivalent of that. Then when you're in quadrant 2, these are the ratios. So this is, as I move around and evaluate along the unit circle, this creates the sine graph. Now, I wish that I kept going, and now this was from 2 pi to 4 pi. It would graph this part over here. All right. And then hopefully you can visualize that happening without seeing the visualization of it. And I wish if I went backwards and went here and then I continued, we'd show the graph over here, but it doesn't. So that's all right. And then cosine kid turned on. It's different. Starting here, high, 0, low, 0, high. Because when I go to my grid for the cosine kid, the cosine, why did I call it the cosine kid? Cosine of 0 is 1, and then sine of a 30 is a half. So cosine of a 30 is root 3 over 2, the other one. Cosine of pi over 4 is root 2 over 2, because that's the same as sine. Sine of a 30 is a half, so cosine of pi over 3 is a half, the other one. Hopefully I said 60. I think I might have screwed up my words there. All right, but then in quadrant 2, cosine's negative. Quadrant 3, cosine's negative. And then quadrant 4, cosine's positive, but with the same ratios. And this would have been a nice little reiteration of the unit circle. Those that are struggling and memorizing that, filling this out, but we just didn't do it with you. Maybe with the ABers I will. But input, output. You know what you're really going to have to do, though? You're really only going to have to do these points. High, middle, and low points. So you're really only going to have to mark 5 points in order to graph a sine. You're not going to have to do all these, you know. Cosine of a pi over 3 is a half. You know, you don't have to do those. It's the high, middles, and lows that are going to be the key. Okay, so this is what I always tell we're going to write this a couple times. I like calling sine is like two bowls latched on together. So sine is like this and then another bowl. And I don't know how I look when you're looking at me on this. It may look in reverse, but maybe the way you guys are looking at me, it should be like this and like that, right? Right? It starts high and then low. All right. But I think I get reversed in the mirror image of this video. I'm not sure. Okay, and then here's another video that Mrs. Cooper's voice is on. So she made this on the calendar. A couple of these. What amplitude is? It's really what I'm going to tell you, and what period is. If you want to hear it from someone else, go ahead. All right. And then this is actually when we're done with all types of graphing. So that's a sine, cosine, a tangent, and then also with up, down, right, left shifts, which is really hard. So they put that on our calendar today. Maybe the first part will be okay. Then it gets complicated and things that we're going to do later. So whatever, those that like to investigate and get a head start on things. Okay, so I like calling sine to. So let's talk about amplitude. Here's what amplitude is, I guess by definition. Amplitude is really, I'm going to simplify this from last hour. It's half of the range covered. It really is. Or another way of looking at it is it's how high and low you go above the midline. All right, that's another way of looking at it. So the midline right here is the x-axis. How high do I go above it? How many units? 1. How low do I go below it? 1. So it's a grand total of 2 units covered. So half of 2 units are covered on the range. So it's an amplitude of 1. I don't know what else to tell you. This is what it is. All right. But it's really the number above and below the midline that you travel. All right. What's the period? The period by definition is the x-axis where one cycle is covered. The x-axis of one cycle. So what is that? 2 pi. What's the domain? What am I allowed to plug in and then cosine? What does it appear to be? Oh, anyone? All real numbers. I was being lazy and writing this. Later we'll write it in interval notation. And what's the range? What does it go from? What to what? -1 to 1. This is going to change. Actually, this is going to change today. When we change the amplitude, it's very simple. Okay, so I'm not going to write all those words for this. Isn't the amplitude the same for cosine? Yes? Yes, Mr. Samuelis. Isn't the period the same for cosine? Oh, I forgot. Why did I call this the cosine kid? I'm probably going to pull a muscle here. Cosine Kid. Anyone ever see the Karate Kid? Not the old version from 1980s, for which Cobra Kai is. Did you see there's going to be a Cobra Kai movie? Did you see who's coming into that movie? The sensei from the new. I don't know how they're going to incorporate that character in there. The Karate Kid with what's his face's son, the guy that slapped someone in the Oscars. What's his name? Will Smith's son. Did anyone ever see that one? Yeah. No. You watch those movies I told you about? You took all last week off. You should have watched movies. All right. Did I talk about the truancy letter that Lexi got? I didn't. Your student has missed at least 4 cumulative days last semester. We get a truancy letter at Manuka. Truancy. I had a student miss. Well, that was you. But you were sick, right? Okay, you were sick. All right. Anyway, 4. I got a truancy letter already. Unbelievable. Anyway, you know why we call it the cosine kid? Oh, I don't know if you could see me here. They would ever see this in the end of the original one. What was this called? What was that called? It was called the crane. Yeah, right? Ow. Okay. So doesn't that look like the cosine kid? The crane? Anyone? Right? Okay. So that's why you're going to remember cosine is the cosine kid, just like the karate kid. All right. So anyway, true. Hey, what's the period? 2 pi. No one's saying anything. I don't know what's going on. There must be something in the water. They must have heard about the A-Bers. I yelled at them this morning. We had a quiz the day before a test. Take a guess what first hour's average was. 70 would have been nice. 54. Then we had a quiz yesterday. Do you know what the average was on that? Now I should preface this for something, but it was 40. All right. I don't know. The weekend, everything just goes out the brain and we know nothing. I don't know. It's killing me. It's killing my demeanor. It's killing my good nature. Anyway, what's the domain? All real. Let's not be lazy. It's all real numbers. So it's negative infinity to infinity. And then what's the range? It's -1 to 1. Got it? Oh no. Okay, so now what have we done? What is this 2 called? I'll give you a 50-50 and some of you will still not answer. That's fine. It's teaching in America right now. But is it a stretch or shrink? 3, 2, 1, go. Ooh, they said stretch. And is it a vertical or horizontal stretch? So it's stretched. Which one? Vertical or horizontal? It is vertical. We should recognize that from just every function's affected the same way. It is. So who is that going to affect? The amplitude or the period? 3, 2, 1, go. The amplitude. As a matter of fact, input, say it. It's very simple to take the parent function and see what happens when I put in 2 in front of it. What's the sine of pi over 2? Just say this number right here. What's the sine of pi over 2? 1. But then what's 1 times 2? 2. Here's a problem. What's the sine of 0? What's that y value? 0. What's 2 times 0? Still 0. So really those stay on 0, but then everything else is stretched. All right. So I'll show you how you're literally going to have to graph these. You're going to have to know that the parent function, I'm just going to go right to it. I can't be cryptic about this. There's nothing to be cryptic about it. Here's our 1, 2, 3, 4 marks. This is still going to have a period of 2 pi because that's not changed. The sine of 0, 0 times 2 is still 0. The sine of pi over 2 is 1, but 1 times 2 is 2. And you got to mark that. So this gets stretched vertically. This changes the amplitude. Then I'll fill in all the other stuff. The sine of pi is still 0. 2 times 0 is still 0. The sine of 3 pi over 2 is -1, but then times 2 makes it -2. So it gets stretched to -2. All right. And then throughout this whole thing, they probably want you to do 2 periods. One, notice I'm skipping one just to give myself space, make it nice little spaced out. Look at your graph paper you picked up. Just use it appropriately, and go from there. 0, high 0.1. Oh, and then here's some things that people do weird with this. They go like this. Do you think that's what happens? Do you think that's what the graph does? Is that a continuation of the flow of things? No, but the other reason is this is quadrant 4. This is quadrant 4 on the unit circle. This is quadrant 4. That's why these are repeated, and I marked that on the other one. That's why those are repeated. It's just going negatively directly, right? When I looked at that, that other thing that we could toggle and pull on the unit circle to show the graph. I wish it did more. I thought I had one in the past that could show more. I know Desmos is a good thing to actually mess with stuff too. But I just use theirs that they have there. It's good. It's good. It's good. I'm not saying anything bad about it. So, how will the table for G of 2, then your high and low points are 2. I don't know. How will the graph compare? That's what I said right here. It's stretched vertically. What is the amplitude? That's the change. The amplitude is now 2. What is the period? No change. 2 pi compared to the parent. What is the domain? It's still all real numbers. Still no change there, but certainly a change in the range. Okay, we go from 2 to -2 now. And then again, hammering down the point, you go 2 up and 2 down from the middle. That's why the amplitude is 2. By the way, amplitude, write this down now before I forget, is always positive no matter what. Whenever you list what the amplitude is, this is a nice little trickery by a teacher to get you to make a silly wrong answer. I think it's deceptive by us to give you a choice of -2 for amplitude. When would that happen? When you see some later ones like people screw these up. When I have a negative in front, they say amplitude is negative. You're gone. You'll get the red pen of vengeance. Oh, I'll show you another time you'll get the red pen of vengeance. It's coming up right here. Okay. Hey, let's look at this. You're supposed to know this. What is this 2? What does this 2 do? First of all, let's do it this way. Is this a vertical or horizontal? Which one is it? It's horizontal. I did that first because I thought you would have gotten that right. You're supposed to. You're supposed to know this. But is it a stretch or a shrink? 3, 2, 1, go. It's a shrink. I heard some people say stretch. And this is good to remind you because this is a perfect AP example for any function. When the multiplier is on the inside of the function, it's a horizontal stretch or shrink, and it's an opposite or an inverse relationship. So actually, it's a horizontal shrink by a half. And that's what you were supposed to know and write as words. And this may be a multiple choice question on any function. Could be quadratic, could be, that'd be weird. But yes, it could. Square root, anything is affected the same way. And that's what we should have gotten from our previous things. But I'm going to do an input output thing. Like, this is what I did last hour. I just went right to it. So what should happen is this, and this is why. This value should be pi. Why? What happens when I plug in pi? What does it become before I do the cosine of it? What does it become? 2 pi. And what's the cosine of 2 pi? Everyone should look right here and tell me what the cosine of 2 pi is. 1. So now at pi, I get 1. And I'm going to go ahead and do that. Did I make 1 the high point there? No, let's do this. Let's scale it appropriately. You don't have to. As long as you mark this as 1, or if you mark this as 1 up there, you'd be okay. It's up to you how many units you use on a graph. Got it? But I wanted to compare this to this last one. All right. If I really truly compared to this last one, I'd put pi here. All right. And then really shrink it. Maybe I'll do that when I compare this to the parents. Hey, what's half of pi? I just said it. What's half of pi? Pi over 2. Hey, what's half of pi over 2? Pi over, come on. And then the only people that struggle on this is people that are fractionally challenged. They have an inability to take fractions and take half of things. All you have to do is multiply the denominator by 2. This really angers me, these things that really, because I've been covering it all year long too. You guys are probably fine. But it's just these things are not the things that should be people struggling with. Hey, you ready for this? 1 pi over 4. let me put that up here. 1 pi over 4. Isn't this 2 pi over 4 right here, right? Because what you have to understand is this distance is pi over 4. This distance is pi over 4. This distance is pi over 4. And that x-axis distance is pi over 4. So I just keep adding pi over 4 to itself to get to the third one, which is, anyone? 3 pi over 4. Wait a minute, I don't get it. Is this 4 pi over 4? Is it or isn't it? Yes. So this is 3 pi over 4. This is how I always find the third value. Because this is the hardest part. All right, when we start graphing these and how you, because this is what you have to do to graph. You have to mark these 4 key positions and mark your y-axis. If you don't have any numbers on there, you get 0 credit, none. The red pen of vengeance. Fat Thor will raise his pen up. Did I tell you about that story, Fat Thor? And oh, you don't. The new girl. All the things you gotta get. You gotta. Okay. Anyway. So -1. All right, and then watch how this happens. Input, say it. What happens when I plug in pi over 2 here? What's 2 times pi over 2? What's 2 times pi over 2? Pi. What's the cosine of pi? Let's cheat and look at the other graph. Oh, the cosine of pi was -1. So that's how this works. That's why this is the low point. I gotta erase that circle. And then what's cosine of pi over 4? Well, when I plug in pi over 4 here, I get 2 times that, which is pi over 2. Cosine of pi over 2 was 0. So this is the 0. And then what's cosine of 0? Still 1. Even if I multiply by 2, I still get 0 and get 1. Oh, and then 3 pi over 4 times 2 is 3 pi over 2. If you look up at the parent graph, that's the 0 value as well. What do you have yet again? The cosine, say it. The cosine kid. Oh, here you go. You ready for the Fat Thor red pen of vengeance raising up in the sky, grabbing lightning and this is good. This is bad. You know, I'm going to stop this graph right here. I'm going to go like this and then make this go like this and then go like this. Why? Why is this person going to get judged by the red pen of vengeance? Or justice. Sorry, not vengeance. Why? You're telling me that the y values go higher than what? 1. This is sloppy. This is sloppy. You've been warned. Video is the evidence. I can pull this video up and remind you that this is why this happened to you. All right. And then, of course, you can do, I'm getting lazy here, negative pi over 4, negative pi over 2, negative 3. I feel like I'm going too far. Nope. And then negative pi, and then the continuation of the graph, the periodicity of it. Whoa. I think I just made up a word there. You can mark those up. Right? And then we could go back up here. What is the amplitude? It's still 1. What is the period, though? You know what it is? It ended up being, I might as well share this, 2 pi, the parent's period, really divided by that 2, which equals pi, the 2 that is in this equation. It is true. And I'm going to have to write that on the next page. All right, things that you're supposed to know. What is the domain? You're never going to have domain issues with cosine and sine. You're going to have domain issues with everything else, though. Just wait. The range in this case was just -1 to 1 because there was no change in the up-down. And then we sketched the graph. I was lazy. I'm supposed to mark these up. I told you to just make them negative. Negative pi over 4, negative pi over 2. Negative 3 pi over 4, negative pi. Okay, now in terms of this baby functions, I said the parents y equals sine x, y equals cosine x. What if we put numbers in these positions? Well, the domain doesn't change. No issues. The range does, because the amplitude is whatever this number is right there. That means the range is from low A to high A. We saw that in the third example or the first one that wasn't the parent. It went from 2 to -2. The period, I kind of just leaked that out in that last one. How did I get a period of pi? It was 2 pi over that 2 in this position. And maybe I can highlight that in a different color. Whatever that number is there, it's 2 pi over that number. That's the stretch shrink. Notice it's an inverted relationship again. It's like 1/2 of 2 pi, right? It's shrunk when I had 2 in that position. Some AP language. We're going to do this again. We're going to put in quotes that sine is 2 bowls in Samuelus's class. And we're going to do a sketch of it real quick with this here. And I'm only going to do the one on the right. So our high-low point is whatever that number is. So we're going to put A and negative A there. And then I got 1, 2, 3, 4 positions here that are important for our high, low, and middle. And the period is 2 pi. No, it's 2 pi over B. That's where it ends. That's where one cycle ends. And then this is nice. This just says f of 0 equals 0. That means sine starts here. And then I could do my 2 bowls. High, 0. That's bowl number 1. Low, 0. That's bowl number 2. And then I am allowed to do those arrows like that. I could do negative 2 pi over b to the left and do another cycle. That's what we got there. What do we call cosine? The cosine, anyone? Kid. You know, maybe you have to watch the Karate Kid movie in order to see the crane at the end. I don't want to give it away, but it's so funny. The kids really enjoyed that movie. We saw it like 8 years ago or whatever. They admitted it's cheesy, but it's cheesy fun. Like 80s movies are cheesy and fun and good stuff. Common themes throughout many of them. Teenager angst and bullies. Bullies were all, I got bullied so bad in high school. Oh, jerks. Everyone was jerks. 2 pi over b again. F of 0 is A and negative A. High points, that's what this means, or cosine kid. Hiya. The crane. Hiya. And then loop those around. Get those crane going. Okay, and I think that's pretty good. All right, blah, 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 blah. Whatever that all says, we're just going to go ahead and graph. Oh, no. So what is the period of this one? You get to see this right here, right? It's right there in front of you. What's the B value? Ah! Get someone sucking the oxygen from this side of the room. What's B value? What's the B value? 1/4. Somebody said it. So here's number 1, understanding that the B value is 1/4. What does that mean the period is? Being able to handle this fraction, what is the answer? 8 pi. I can do an input output. Oh, and I said I was going to do this. I know I bore you when I do this. Hey, how would this graph compare to the parents? Let's put that graph next to the parent real quick. What would end up happening is this. It would be this picture. I'm trying to pick a different color. High. Oh, and then the next high point would be here, and this would be the low point. So this is what we would have next to the parent graph, that one I just did there, right? Right. So another thing I want you to understand is, do you know how many cosine kids are from 0 to 2 pi? How many? Hold on, don't answer that question. I'll answer it right now. How many cosines do you see there? How many? How many? What's that number right there? 2. So you get 2 cosine kids from 0 to 2 pi. That's the shrinking. So that's another way you can analyze that number there. All right, I'll leave that up there. So I went over to this one. How many cosine kids will you see from 0 to 2 pi? Say that answer. 1/4, because this is stretched horizontally. All right, this is a nice little connection to things we did like in September, maybe, talking about horizontal and vertical stretches and shrinks. Horizontal stretches and shrinks are inversely related. Inversely related. So this is easy. This is 8 pi. What time is it behind me? What is it? And 120. 2 pi, 4 pi, what? This one's easy. All right, and then I don't probably have enough time for this one. This is just 1 in front. So cosine kid, let's make this 1 and this -1. You have to have these marked or else. Cosine kid, hiya! And then it ends at the high point. Wait, how does that happen? I barely have time for this. What happens when I plug in 8 pi in for x? What's 8 pi divided by 4? What's 8 pi divided by 4? 2 pi. What's the cosine of 2 pi? 1. What's 4 pi divided by 4? Pi. What's the cosine of pi? -1. What's 6 pi divided by 4? 3 pi over 2. What's cosine of 3 pi over 2? 0. What's 2 pi over 4? Pi over 2. What's cosine of pi over 2? 0. Right? So this is why this works. This is why this works. And then I'm running out of time. -2 pi, -4 pi, -6 pi, -8 pi. You feel free to write those. Back to 0, back to low, back to 0, back to high. There's another cosine kid. You can mark those. Domain, all real numbers always for sine and cosine. Range, there was no amplitude change, so it's -1 to 1. So the amplitude is 1, right? And these are synonymous with each other. These are connected. The period, though, was 2 pi over a fourth, which I already calculated up there as 8 pi, and I went ahead and graphed it. So period's 8 pi. Pretty easy, right? Unless you're fractionally challenged. What's 2 pi over 2/3? What is it? Here we go. 1, 2, 3, 4. Now notice I'm doing the same thing every single one because it doesn't matter. What matters is what you put on the x-axis. All these are different if you looked at them together on the same grid. But here we go. What's half of 3 pi? What's half of 3 pi? 3 pi over 2. What's half of 3 pi over 2? 3 pi over... This really makes me sad, those that can't come up with 3 pi over 4. You just multiply the denominator by 2. At least be a robot and get that part right. All right, watch this. 3 pi over 4, because now all these distances are 3 pi over 4 away from each other. All of them. So I'm going to keep adding 3 pi over 4 to itself. What's 3 pi over 4 plus 3 pi over 4? 6 pi over 4. Hey, is this 6 pi over 4 when you reduce it? So what's the next one? Someone last hour said 7 pi over 4. No, it's 9 pi over 4. The discount double check, is this 12 pi over 4? Is this 12 pi over 4? Darn tootin'. Do not write these up here. And maybe at the beginning stages of your understanding, do it. This is the one I really key off of, though. This is the one that gets wrong all the time, let's just say. And let's not say by who. All right? And they haven't done this yet, so I can't. But them of the past, half of my class can't get that value. Fractions. That's all it is. Choking on those words. All right, and then what does this mean? What am I going to do? We don't have time for this. Flip. I used to ask this question in case someone wasn't paying attention. What's f of 0 then? How does science start? Does it start high, low, or middle? Where does it start? Middle. So what's f of 0? Everyone say it. 0. What's f of 3 pi over 4? High, middle, or low when I have a negative in front of the function? Low. There's the flippage. This is at -1. So now you have to account for x-axis reflections. It's supposed to be the high point, but now it's the low point. Hey, everyone, what's f of 3 pi over 2? High, middle, or low? What is it? Middle, which is 0. What's f of 9 pi over 4? High or low? High. What's f of 3 pi? 0. This is the sine bowls, except they've been flipped. And now these are the bowls. Cut and paste your x values as negatives and then do the same graph over here. Oh, this is tough. I got to go 2 marks there. Okay, I think I did it. But then we mark them -3 pi over 4, -3 pi over 2, -9 pi over 4, and -3 pi. I'm running out of time. Domain is all real numbers. The range is still the same. Even though it was inverted, we still cover from -1 to 1. That's because the amplitude is still 1. And the period in this case was 3 pi as denoted up with my work there. Oh, 4 minutes. This happens in real world questions. I really thought I showed you an AP video of Ferris wheel, and then you start here, then you go up, and then you come back down, and then they graphed your height over time. And I thought I showed you that, but maybe I didn't. I'm not really sure. If I did, it was in August. All right, and it was a long time ago. But this happens a lot in real world questions where my period doesn't have pi in it, because the period is actually time. So 2 would actually mean maybe 2 seconds in a real world question. This is true. So the period is just a number 2. 1, 2, 3, 4. What's half of 2? No time. 1. What's half of 1? No time. 1 half. 1 half, 2 halves. Say it. 3 halves. That's the one I'm going to check. All right, and then I do have an amplitude change and a flip. And I have a cosine kid. So how does a cosine kid start? What's f of 0? Is it high, middle, or low with that negative in front? Which one is it? Low. Pat yourself on the back if you got that correct. What's f of 1 half? High, middle, or low? Middle or 0. F of a half is 0. What's f of 1? 2, 0, or -2? 2. And I can input, say it. I can input in these and prove that. I plug in 1. 1 times pi is pi. Cosine of pi is -1, but times -2 is 2. Boom. Input outputting can also do all of this. Okay, and because of shortness of time, cut and paste those x values, cut and paste the same graph over to the left. Domain, all real numbers. Range is from -2 to 2. Hopefully I did that right in the last hour. I felt like I was going fast because the amplitude is 2 and the period is 2, weirdly. All right. All right. So you picked up some graph paper because in the homework, it's on the calendar as that book. Where is the mouse? You can see what I go through. The mouse is not showing up. Where is the arrow? You guys see this? There it is. It finally appeared. Oh,